Bathes and protects mucosal surfaces. Why would your mucosa need protection?
It's a barrier.
It's a barrier, right? Everything in town's going to crawl in my mouth or whatever. I want to put landmines there. So every place that something can get in, I'm going to put some antibodies to keep you out. Right? So prevent attachment of pathogens to my parts. Right? So IgAs, body fluids. IgDs are always on the B, on the surface of the B cell. Okay, so all B cells make antibodies. It doesn't stay attached to the B cell. And what are they for? Why would you need them on a B cell? Activation. That's what tells them, that's what they bind to. So it's an activator. IgE. Go down to the bottom one. Where do you find IgEs?
Allergies.
Digestive tract, respiratory tract. You can summarize that as tubing. How's that for a scientific word? All your body tubing would contain IgEs. Mucosa, tonsils, also skin. So skin's in there. Read the next paragraph over that's underlined in red. Tell me what the magic word you see is.
Histamine.
Histamine. What's the job of histamine again? These ones are the inflammatory antibodies. They help you get swollen. So another way to say this is they call allergies. When you get an allergy, what part of your body gets all swollen? Your eyes can, but your mouth, right? Your skin, your lungs. That's because the IgE antibodies are being made, and they cause you to histamine and start getting a response. We call that an allergy. That means those antibodies are binding to something in your skin. The peanut butter in your sandwich is finding an antibody somewhere in your gut and reacting. Yes?
Well, this doesn't confuse anything, but is this related to mast cells?
Yeah. A mast cell basically is a histamine-releasing cell in response to an IgE.
Okay.
So the IgEs basically activate the mast cells. So IgG. IgG, my favorite. It's in the plasma. Or the blood, if you want to call it that. That's fine. This one is floating in your bloodstream. So if there's something in my blood, that felt great. That's what you're going to do. All right? Last one, IgM. This one's in two places. It's either on the B or free. It can exist in multiple places. And if you read what it does, that's one of the first ones you make, and then it does a bunch of nice things. But basically, it's similar to a D. So you're supposed to know the letter, kind of where it's found. Okay? And there's a stupid little song to help you. White guy dancing. Here we go. All right. IgAs can flow away. Things that flow out of my body are what? Fluids like tears, semen, milk. Those are things that flow out of me. So IgAs can flow away. IgD is on the B. IgE is allergy. IgD is bloody baby. If you're wondering about that one, read the G. Where's it found? Also goes to my where? Crosses to the baby, so in utero. So IgD is bloody baby. And I don't know how to rhyme IgM. I'm a white guy. I have no idea. Right? So I learned a little rhyme that remembers.
Well, you're going to have to sing again.
Am I? No.
Yeah.
I'm the next American Idol. There we go. IgAs can flow away. IgD is on the B. IgE is allergy. IgG is bloody baby. IgM. I don't know. Primary membrane bound system. Yeah. You can go up with a minute. So if something's invading your mouth, it would be an A or possibly an E. That would be trying to hold it down. If you're pregnant, congratulations, that's going to be IgG going to your baby to protect baby from whatever you're remembering. If you are a B cell by yourself, you're going to have an IgD or an IgM. So you should know where they're found. They're all going to do the same thing. They're all going to stick to something. Just different locations and kind of different jobs. not done yet.
You don't need to know the function, just the.
They're all the same, basically stick. The only one slightly different is the allergic response of E. But they're all basically going to stick to something. Okay. We're not quite done yet. Notice I said some of the B cells make antibodies. So in this picture again, here are my B cells, plasma B cells. Here are the antibodies they make. Hey, here's somebody who's not making antibody. What is that? A memory cell. So you have memory T cells, you also have a memory B cell. So step 6. Some B cells stay inactive. We call those the memory cells, the reserves. So you have memory cells for Bs, you have memory cells for Ts. They remember the types of things to kill. Right? Same as a T. So next time I get infected, I know what type of antibody to make without having to listen to all that over there. Make sense? So let's go back to our animation, which is here. So we just did our T cell response, but remember your body would also do a B cell response using the same primary steps. So we activated our APC, we activated our helper T cell. The helper T cell now is going to turn on your B cells. Here are the B cells.
B cells also come in millions of different types, each able to recognize a particular antigen. When B cells become activated by T helper cells, they differentiate into plasma cells. These plasma cells become antibody-producing factories, flooding the bloodstream with antibodies that can bind to the antigen involved in this infection.
Now do one of these categories.
Antibodies bind to the antigens on the surfaces of the pathogens, marking them for destruction by macrophages. Some of the B cells do not turn into antibody factories, but instead become memory B cells that may survive for several decades. Because of these memory B cells, the secondary immune response to a future infection by the same pathogen is swifter and stronger.
Why would that be? Why would it be faster and stronger the second time?
Because we make new antibodies.
Yeah, I've already been trained, it's like a veteran. I've already been taught what to do. I remember the antigen. All I have to do is sit there and be told, go kill. Right? I don't have to wait and be taught. I've already learned. Just like your reserves are always better troops, that's the idea here. Right? They already know what to do, therefore they don't have to waste time learning it.
This powerful secondary immune response is what gives immunity to some diseases after you have had them once or after you have been vaccinated.
So once you teach the immune system what to kill the first time, it should remember it for the next time.
We get boosters shots because those memory B cells go away.
Or we just want to be guaranteed that they will be remembering really well.
Okay.
So booster is just a way to remind the immune system. There's this weird, not that you notice, but there's this pattern. The more times you get exposed in the real world to stuff, the more this system keeps remembering. So colds are everywhere. You're always getting them. So you always keep building up memory to the colds you've had. Something like, tetanus or typhus or whatever. You don't see that often. So one of the fears is, well, you go off, you haven't seen this for 15 years, they might just sort of forget about it. So we'll give you a booster once in a while just to remind the system. Basically amplifies memory. So it's similar to the primary response.
Have people been immunized to tetanus before and still gotten it years later, and that's why they do it, or can you actually check and see if there's still memory B cells?
The way to do is a titer test. You can give yourself, you take the cells, add them to the antigen, see if they respond, it's called titer, and that's the expensive way to test it. The easy way is just take the shot and just go home. It's just cheap rolling around. But a titer test proves that your antibodies, it doesn't prove the T cell system's working, but indirectly. It just proves your antibodies found an antigen. It's basically like your blood typing. If I mix the two and it clots, there had to be the two things. So a titer test is a biochemical way to sort of prove active. That's why, like EMTs, they require a titer for some of the vaccines to prove it actually took. But in the real way, it doesn't happen. Remember chickenpox parties? Am I the one that's old enough to remember that?
Yeah.
Right, your mom just sent you with everybody, have chickenpox, have fun. Now they require proof of titer because you could have been at the party but maybe not gotten enough memory. and then we just sue people, right? So that's how this works.
So we sue
But
people.
that's what titer test does. But just to show you this concept one more time, here's what you learn. If I go step 1 to step 6, just in T's or B's, doesn't matter which one, this is showing antibody level, this is a B cell, over weeks. So how long does it take my immune system to get the memo from the boss and start to work?
2 weeks.
Yeah, about a week to even start, 2 weeks to make my response. That's the primary response. The first time you're exposed, it takes 2 weeks to get your army to the front. Right? The military is never efficient. Yeah.
Is that the same thing as it takes about a 2-week incubation period for a lot of these different germs that we're trying to get now?
Kind of.
Do they kind of?
That's usually why most things kind of go away after 2 weeks. It took you 2 weeks to fight it off. You get the army, and then you fight it off the next 2 weeks later. Right?
Is this for B?
This is for B, but T's would be the same graph. They just don't make an antibody level. So in real life, it takes you about 2 weeks to actually get the ball rolling. Your helper T's have to find it, give the memo, reproduce your bone marrow. It takes them forever. So you get sick in here. If you survive, you now have memory cells. How long does it take them? Let's find out. You went from 2 weeks to about 2 days. And how many antibodies are you making? About twice as much. Swifter, faster, stronger. And every time I get exposed again, I make more memory cells, which would be even faster and stronger. So the more times I get exposed, the more memory I create, the more reserves I have, the stronger I can respond the second, third, fourth, fifth time. So you killed the flu before the flu kills you. Here the flu kills me first because I'm too slow. It took you 2 weeks to get to the front, you're already lost to Ukraine. Right? But here you go, now you're going to fight them off. That's the purpose of vaccinations, right? When you vaccinate your kids, you're giving them number 1. I give my kid the MMR, whatever. 2 weeks from now, they have memory. So when MMR hits them, bam, they stop having whooping cough before whooping cough kills them. That's the concept of vaccine. You're doing the first to build up the memory for the real thing, second time.
What's happened when you're only sick for like 2-3 days?
That's normal response to a vaccine. Because in a vaccine, it turns on your immune system. So any vaccine will cause a vaccination response. You'll feel tired, you may get a slight fever. That means the vaccine's actually working. You're turning on your immune system.
Well, I mean, if you're not being vaccinated, you just get sick from
Then your immune system must have been pretty good. So, yeah.
So if your body doesn't show the symptoms, then that's not as good as your body showing the symptoms.
Well, it depends. If you don't show symptoms at all, that means your immune system must be fantastic. Because it
Okay.
fought off whatever before it got a hold, or it's a weak virus.
Okay.
Normally when people get a vaccine, they show some slight symptom
Like
from the localized effect.
Yeah.
The goal is to get the second graph. Yeah.
Is this an always thing? You're always making antibodies against something?
Yes. Under normal conditions, you will always produce antibodies upon exposure.
Only upon exposure?
Yes. So what happens is, like these graphs show, if nothing is in there, the military stands down. The memory cells stay there. The antibodies wear off their protein, right? They don't last forever. And about 2 weeks later, 4 weeks, a month, they kind of go away. But the memory cells are still there. So what you see then is the spike would be next time. This would stay higher longer, and then eventually that would drop down. And you keep doing that response.
Is there a relationship between sleep and antibodies?
In general, kind of through stress, I know that one. The more stressed you are, the less sleep you get, the less antibodies you make.
So would your body automatically sleep more in order to make more antibodies?
It does tire you. This process is tiring. That's why you want to sleep during the flu. I don't know specifically if sleep would affect the direct number. Make sense on your secondary primary response? So to summarize this whole big ugly mess, let me show you this picture here. Let's walk through it. Here is my exposure. Some guy on the bus just spat on me or whatever. I'm now exposed with some antigen. It broke through my skin, it broke through everything, it's raising hell. All right, we have to turn on the helper T. So here's my body cell. It's going to eat the thing, whatever it is. I'm now magically an antigen-presenting cell. And who am I presenting this to?
T-cells.
Which kind of T cell?
Helper.
Now, I got to tell the general, right? So there's my helper T cell. The helper T cell will turn on both systems. I'm going to turn on the B's, and I'm going to turn on the T's. The first 3 steps are always the same. If I turn on T's, I'm going to proliferate my cytotoxic T's, which go down here, and make some that kill the little assassin ninja guys, and some that remember. That way, I'll punch holes in the cells, and if you show up again, I remember your face to kill you next time. That's your shoulder. Don't ever show your face in this bar again. That's the concept. Right? The B cell system, I turn them on. Plasma cells make antibodies, the flypaper. They stick to antigens, making it easier to attack them. You can't infect me if you can't move. And some remember. So the next time I get exposed, I can make more antibodies more faster. Is that even right? More antibodies faster. Right? And there's also, believe it or not, there's a memory helper T. So the more time exposed, the more generals I have remembering how to order the memory cells to do their job. So your military is getting better and better the more you fight the same enemy, which makes sense. You get better and better at learning what to do.
Does your body usually have both pathways
Yes.
together?
Normally. In fact, you want both pathways because the helper T's can only the T cells can only kill something that's infected. And they really can't stop you from moving to another cell. The antibodies can stop you from moving to another cell. So you're trapped while I kill you. So between both of them, you can't get out and you can't get anywhere else. So it's a pretty good system. Yes.
Are we always exposed to something? I noticed that you
hope
said
so.
that you get the flu or something during finals. Is that because you're always around flu and you're just compromised?
Yeah. If you're a school teacher, you're always going to get sick the first week of class. Because all of a sudden I get exposed to all sorts of new shapes from all of you I've never seen before. I'm stressed out. It takes me 2 weeks to figure out how to fight what you just sneezed on the first day of class. So I'm sick. Right? But then I'll learn, so by the end of the year, you're not making me nearly as sick. Or if you're a parent, okay, if you have kids, they have runny noses in the first 4 years of their life, right? Because they don't have any memory. As they get further in school, they have less and less colds and flus because they're learning more and more of their environment. Now, if you pick up and move to Mexico City tomorrow, guess what all of you will have? Runny noses, because you don't remember anything from Mexico City, or Ukraine, or wherever. So once I change my environment, or the people, I have to relearn the new pathogens. So lucky me, I always get sick twice every term. First week, last week. Thank you all.
Why are you stressed during finals?
Because I have to get the finals in 2 days and the grade's done, then you're yelling at me about why an 85% on an A, and then I have to cry because you don't get nursing school, and get ready for next term, and people write me why I don't have my... I had somebody email me 2 weeks ago why my fall syllabus isn't done yet.
No.
I don't know what I'm teaching for fall. Why am I going to know what page am I doing October 15th? I don't know what page you're doing October 15th. I don't know what I'm doing October 15th. What month is October 15th even in? I don't know. So yeah, the stress can just decline, right? So anyway. But this is the concept. So as long as I'm getting exposed to the same things, I'll keep remembering it. This is partly what they call the hygiene hypothesis. The cleaner your environment, the more diseases you get.
Huh? Oh.
Because you have less and less memory when the real thing hits. So if you bleach your house, your kids are going to get sicker.
So you're
Because they
saying
wouldn't
it's
have
better
had
if it's in a
anything.
dirty house?
Right. Kids in slums don't have allergies. They had all sorts of other things that have allergies. Because if you live in squalor, you remember everything. Well, hygiene hypothesis, yeah. It's weird. The cleaner your environment, the less memory you develop.
So is it good to let your children crawl on the floor and the ground and eat everything?
On a farm, if it wasn't moving, the kids could bite it. It's fine.
Are allergies genetic too, though?
There's a genetic predisposition, but the #1 factor is the cleanliness of the environment. Did you ever hear about the East German study? Oh, this is worth listening to. When Germany reunited, you had East Germany, which was a polluted hell, and West Germany, which was pristine. Now think about it. Germans would be kind of a uniform genetics, right? Uniform kind of diet, language, everything, right? So it's a good study. They looked at allergies in East Germany, which were basically almost zero. Allergies in West Germany were sky high. Now they were reunified. So East Germany now has cleaned up their act. Their allergy rate now is equivalent to the West in 20 years. The only change was removing the pollution. Same diet, same people, everything. The only change was the pollution, and now allergies are equivalent to 2 sides. Proving that the amount of pollution was somehow inversely proportional to the amount of allergies. So as you make your world cleaner, your kids are more likely to get allergies because they're less exposed to allergens. Yes.
So,
hygiene process.
if that's the case, I mean, I'm sure it is, but why are children of smokers more likely to get allergies then?
Smoking, unfortunately, reduces the immune function.
So it's
smoking
not-
would be good if it was just smoke.
Uh-huh.
But if it's nicotine and all that bad stuff, then it actually turns off this process. So it would work if you could take the bad stuff out of the smoke.
How does it reduce this?
No one knows.
Oh, okay.
But here's what happens in an allergy. Let's say you're allergic to peanut butter. There's peanut butter. Right? Peanut butter is a protein, has a shape. For some reason, your immune system gets a whiff of peanut butter and says, I don't like peanut butter. Peanut butter's evil. I'm going to attack peanut butter. Helper T cell says, kill peanut butter. So it tells your plasma cells to make antibodies. Hey, what kind of antibodies are they? What do IgEs do? Histamine and all like that. So I'm going to make all these antibodies against peanut butter. Great. They attach to your body cells, and that's cool. The first time you have peanut butter. Remember, it takes 2 weeks to do something. But what else do you make besides the antibodies? What else do you make when you're exposed?
Memory.
You make memory cells that remember the peanut butter. Great. So now the next time you have peanut butter, you've already learned to attack peanut butter. You're better, faster, stronger. So now the peanut butter sticks to your B cells. They go gaga because, hey, I know you. I'm going to flood you with histamine. Histamine causes what? Let's see. Leaky, lots of snot, lots of bad things, because it thinks peanut butter is trying to kill you. You call that an allergy and an anaphylactic shock. But that's your immune system doing its job. It's trying to kill the peanut butter. Unfortunately, peanut butter shouldn't kill you. Right?
I have a question. So, with babies, why do they give newborns, even though they have immune, they don't have very good immune systems, why would they give them a vaccination?
Because they would have to have a vaccine to fight off whatever they'd be exposed to. Once you're out of the womb, you have 6 weeks left of immunity.
Mm-hmm.
So if you don't have the vaccine, remember it takes 2 weeks to build up memory. So the longer you wait, the more chance this child will get something before their memory cells are established.
Okay.
Unless you're weaning, then the idea is the sooner I can build up your memory, the sooner I can prevent.
So how long does the immunities last while you're breastfeeding?
6 weeks past weaning, as long as you. So the antibody lives 6 weeks. That's the norm.
So if you have a 3-year-old, then it's
6 weeks past weaning.
cool. Okay.
But the problem is, you can't always. What doctors would argue, you can't always guarantee mom has been exposed. Right? You're only going to transfer what mom had exposure to. So if mom wasn't exposed to varicella, baby's not going to be memory to varicella because you're not passing on antibodies to varicella. So you have to give the kid the shot because mom didn't have a shot. That's the other one of the problems with people not vaccinating is mom now doesn't have the immune system anyway. So it passes on.
Well, doesn't it pass through the placenta and then...
The antibodies do.
Isn't it different antibodies comparative to colostrum and breast milk?
Well, colostrum would be A, fetus would be G, but
Okay.
they're still going to be for the same thing.
Oh, okay.
So once you give birth, you lose the G. Once you put weaning, you lose the A. But both of them would be for the same antigen. So if mom doesn't have the antigen in her body anyway, you're not going to pass on anything for whatever it is. That's why your baby can get a cold or flu. If you catch it, mom, baby will catch it because neither of you have the memory. If you don't catch it, baby won't. Okay, allergens? Let me
Yes.
show you a picture of this real fast. Because I know you love this so. Which is...
Some people develop an allergic reaction or hypersensitivity when exposed to substances such as dust, pollens, animal dander, or penicillin.
So notice the phrasing hypersensitivity. You shouldn't care about peanut butter. Nothing in your body should give a rip about peanut butter, but you just get really sensitive to it, and that's what we call an allergy. So who do you think in this whole process makes that decision of whether or not you should care about peanut butter or not? What cell makes decisions?
The helper T.
The helper T. So the helper T cell, for some reason, says, I want to kill peanut butter. Go nuclear on peanut butter. Your peanut butter binds, and the helper T cell says destroy peanut butter. So the helper T cell is making a bad decision, a bad call about peanut butter, and that's what makes you sensitive to it.
This hypersensitivity is mediated by IgE.
Indeed.
Sensitization occurs when the antigen makes contact with some part of the body. The antigen is taken up, processed by antigen-presenting cells and presented on a Class II MHC to T helper cells.
So here's my helper, just 1, 2, 3, right? That's no different than a flu or a cold. I found it, I present it. At this stage, the helper T cell should have just said, who cares, and walked off. But instead it wants to, saber rattle and say, let's go kill peanut butter.
Does the helper T cell also deal with autoimmune?
In a way, yes.
How?
The helper T cell should not order an immune response, but that's also partly due to the TSR, which is, it could be either one.
Tissues under the mucous membranes are rich in B cells committed to IgE production, and IgE-producing cells are more abundant in persons susceptible to allergies.
Lucky you.
The T helper cells produce cytokines, which stimulate these B cells to proliferate and differentiate into IgE-producing plasma cells.
Here we go. There you go, barbed wire.
As IgE is produced in specific areas of the body, the IgE molecules attach via their constant regions to receptors on nearby mast cells. Mast cells contain granules packed with chemicals that induce a hypersensitivity response. Once attached, the IgE molecules can survive for many weeks.
Lucky you.
The individual is now sensitized to the antigen. When exposed to the antigen for a second time, the antigen binds to the IgE antibodies on the mast cells.
Remember, the first time I learned, the second time I remember. So you've learned it now it's time to fight it off the second time.
To trigger a response, two cell-bound IgE molecules must react with a specific antigen. Within seconds of the reaction, the mast cell releases histamine and other mediators of the inflammatory response from the granules, triggering a variety of symptoms.
Such as what you learned last time. So to your body, the peanut butter is an invader. We need to kill the peanut butter. So flood your body with white blood cells, get red, get swollen. To you, that's crummy. But to your body, it's got, hey, I was told to go kill peanut butter. Don't blame them, just follow orders. Right? That's kind of the logic here. Make sense?
Mm-hmm.
All right. That's called an allergy. Now there's a related word, which is exactly the opposite, which we're going to learn over here. And that is the reverse of that. Someone tell me what it means to be immunotolerant.
Tolerant to an allergy.
That's right. And when you're tolerant, you don't attack stuff before you see it. So sometimes this is called a hyposensitivity. Meaning your body just doesn't care. Allergy is a hypersensitivity. You overreact to peanut butter. In immunotolerance, I don't give a rip one way or the other about peanut butter. And what do you think controls, again, whether or not you are overexcited or underexcited?
Helper T.
The helper T.
But that means that the thymus controls that.
Yes. So it can be thyroid, thymus, or it can just be the helper Ts. So if you have an allergy, you may go to an immunologist who does a tolerance training. They will try to teach your helper Ts to go from hating peanut butter to being peanut butter's BFF. And that's what they're trying to do by exposing you to peanut butter over and over to try to convince your helper Ts peanut butter is not the enemy. The flu is the enemy, not the peanut butter.
But what about if you aren't allergic to peanut butter and then you develop an allergy to peanut butter? Can you go backwards?
Yes.
By being exposed to it more?
Yes, but you make sure you're doing it with a professional. Don't do this at home. Because
Isn't
people do that. They'll just take peanut butter in their mouth and you're dead. Right?
Isn't that why a lot of pediatricians are starting to recommend to introduce potentially allergen-prone foods to children younger than
Yes.
they used to?
Yes.
Oh, like strawberries and
Yes.
peanut butter.
My pediatrician told me to try scrambled eggs with my son when
Yeah.
he was like 6 to 8 months, and it used to be don't bring them anywhere near
Right.
whole eggs until like 18 months.
Right. That was that whole hygiene thing.
Yeah.
You thought by removing foods from kids somehow, but what happened was allergies went up because all of a sudden one day you're a 2-year-old you see peanut butter or strawberries the first day of your life, your immune system doesn't know what the hell it is, so it says, hey, it must be bad. And then you got an allergy.
Are they still saying that about honey, raw?
Well, honey is because of botulism. That you're not supposed to have. That's a different, that's not this. That's simply botulism. But the idea now is, you know, the more exposure you have, again, don't do this at home. Don't just start popping peanut butter because you can die.
Oh my goodness.
But the concept is immunologists can train your helper Ts to shift from hating to liking. And that's called
Why do
tolerance.
some adults develop food allergies? Like I developed a food allergy to mangoes. Like when I was 18, all of a sudden I ate some and my whole mouth swelled.
One day your helper T cell said, I hate mangoes.
Don't you stop making the enzyme too? Doesn't that play a part? As you
It
get
can.
older, you stop
You
making
can
the
if you get more
enzyme.
digestive proteins. But
But that's
generally,
like
your helper
Mars
T
on
cells are
allergy.
making a weird call. So wordless trivia, I have honeybees. The rule on honeybees is you always get stung all the time. It always hurts. Don't get me wrong, it always hurts, right? But by constantly getting stung, at some point I don't react to it anymore. It still hurts, but I stop swelling. Because the more times I get stung by the honeybee, I'm trying to teach my helper Ts to ignore the honeybee. If you do it all day long, no one cares. The first thing of the year, though, you always do it with someone near you. Because over winter, when you're not with the bees, your helper Ts could forget, you get stung, you've seen it before, you're dead in the bee yard in 3 minutes.
Oh my goodness.
Beekeepers have done that. So you always get stung once with someone there, and then if you live, you keep getting stung all the time. Because you get tolerant of the pain.
Do you bring your kids into it? Hey kid, it's
No,
okay.
I thought your memory cells lasted for decades.
Yeah.
They do, but what happens in allergies sometimes is the helper Ts can like getting a mango at 18. One day your helper Ts can just say, I don't remember this honeybee thing, so I'm going to kill you now. So you're trying to constantly keep tolerance to them. Yes?
Is that why, like, you have to get stung by a bee first, and like nothing happens,
That's
and
right.
then you get stung again, then you might die?
That's right, because the first time, all you did was make the memory. The second bee sting is why you end up on the ground. And every bee sting thereafter is worse. The first time you have peanut butter, you're fine. Second time, third time, fourth time, it gets worse. Yeah.
So I read that you can like acquire allergies from getting an organ transplant.
Yes, you can.
So can you acquire tolerance? Like say that could you like learn tolerance from the cells that were like in your heart or whatever?
They think you can, but no one's checked that hypothesis.
That'd be cool. I mean that'd be an extreme way to do it, but.
So let's think about when you're going to be tolerant. There's other times, besides beekeepers. Every pregnant female has to use that same concept. Why would you have to be immunotolerant as a pregnant female?
So you don't kill your baby.
Your baby's not you, right? You get pregnant, that's not you. Your immune system is going to build up memory for your baby's antigens, but you can't have them work. So therefore, your helper Ts have to be taught, tolerate my baby, because otherwise you're going to kill it in 3 days, because that's your job. So when you're pregnant, your